What is solid principle? So we should know that solid principle, it's a very essential to know when we build a application using object orientation programming, that means OOPS concept. And particularly on that time, this is a design pattern we should know, and we should familiar with this, as that we not think after developing the application before or building the application. We took right step, as that the application what we develop, it is not create a problem in long time, when we have to do some required to do some upgradation, modification and require on that application. And it will reduce the testing time. Not only that, it is saving a lots of time to roll out the application, inter application after enhancement in the production. So solid principle, S stand for single responsibility principle, and O stands for open close principle, L stands for Liskov substitution principle, I for interface segregation principle, and after the last one is D for or dependency inversion principle. So we know each and every principle one by one, definitely with some example. So single responsibility principle, it says that when a particular function or class should be responsible for or uh, mm, one purpose, that means it should not be a change for other class. Actually, as for example, there is a user class, and on that user class, let's say there is example, there is two method, get name and get email. And on the user class there is one method or uh, logged user activity. So as per single responsible principle, it is not allowed that in user class you keep the user log activity, as because log activity, it's a different things. We should create another new class as with log activity, and there we should implement this method. As for example, suppose the user log activity today we implement by using writing the log when each and every user logged in the application. Their logging history we track in a file, that means file code content we write in a file. It is required maybe in future we write the same thing in the, instead of writing in a file, we write the same thing in the database. So what happened on that time, we have to change in the existing user class, and for that reason, and each and every place where we implement or call this particular user object at, and each and every place we have to check due to these changes our existing code base is broken or not, or to but instead of that, if we design in such a way that we use user class and logger class separately, and in logger, after that, and in logger class I pass the user object, and we write in database or whatever. So if in future required to change, we just change in the logger class, not in the user class. So on that case, if we require any changes, so we just changes in the logger related each and every page. So in this case, it is easier to unit test is easier, and we not change the test the entire site, right, and it is not taking too much time. So this approach we should follow. And the second thing is open close principle. That means any class or any entity is open for extension, close for modification. So in this principle, actually what we have to do, so let's assume there is a let's up example, one class, um, payment class, and there is a method process. So in this payment class there is a method process, and on that process method or we are implementing many more payment gateway. Let's example, if payment gateway is equal to the credit card, then we process the credit card. If payment gateway is equal to phone pay, then we are doing something. In if else condition, we in process method we are implementing these things. The drawback of this method in general, in future, if there is a upgradation required, that means extra feature need to be implemented on that at application, that we are adding 2-3 more payment gateway, that means Apple Pay, Google Pay, and Paytm. On that time, what we have to do, we have to touch on the we have to write down just changes in the existing class. In if else condition, we have to add many more if else logic. And the problem where we if the object is used, each and every place we have to check, and if there is a error is occur, and for that some deployment, if we deploy this product in production, and on that time it's very difficult to roll back. But instead of that, if we create in the design in such a way that each and every payment process, if we create a separate class, say for example, one interface for payment interface, there is a method process. This is a just public abstract method. So in this interface I don't need to implement this. After that I am implement and one class, and in this class I implement the interface, payment interface. So let's assume that credit card payment, and implement the payment process. After that I implement and Google Pay payment, and implement the same interface. In this way, in future 2-3 more payment interface I have to need to implement in the existing system. So I just implement all the class, and on those class I just implement the same interface. So in this way it's very generic, and in future if we develop many more payment gateway, it will not impacted. For the newly added at payment gateway only I have to test, and it's easy to understand. So it is better design pattern. So we should follow, and we should think in this way before start our application. And the third thing is Liskov substitution principle. In this method it is said that subtypes should be substitutable for their or base class. So subtypes should be substitutable for their base class. So let's assume there is a class bird, and there is a method fly. So this class bird and have fly. So if we extend this class for, let's for example, penguin. In this case the, it is not the properly, it's violet, as because penguin is not flying, it's just walking. So for this we have to write something, throw new arrow or something, as because penguin not fly, so it's not generic. So when we design, on that time we design in such a way that it should be very generic. So instead of that, if we just create a abstract class, let's assume um, bird, and the method, or instead of fly we just give a move. So on that move method, or it is applicable for penguin, parrot, or any fly. So for penguin it's move, parrot it's flying. So it's a generic thing. So we should think in this way, Liskov substitution principle. And the fourth thing is a interface segregation principle. So interface segregation principle, it is said that that particularly uh, clients should not be forced to implement the interface what is not required. Suppose let's assume there is a particular uh, class uh, workable interface, and on that workable interface there is a many more method, public method, abstract method, maybe workable workable interface. The method name is work, sleep, and eat. So after that I am just implementing this interface for our human worker. So when we implement this human worker, on that time it's fine. I implement and the eat, sleep, and work, as because for human eating, sleeping, and working is natural. But think, if we have a robot worker, for robot worker, robot never eat, never sleep, he robot just work. So for robot it's violate, as because robot not eat, not sleep. So we should design in such a way that as per require, I unnecessary actually if we fixed in the interface all those that means eat, sleep, and work, then it's violate for robot. So we should design in such a way that anyone can on the implement in on demand. So we should develop three different interface instead of one interface. First interface is a workable interface, second interface is eatable interface, third interface is sleepable interface. And for the particular human worker, I implement three interface at a time: workable interface, sleeping interface, and eatable interface. But for robot, I just need to implement and workable interface. I don't need to implement eatable interface, sleepable interface. So if we design in such a way, then our design is more accurate, and it will not take time to testing, and it's more proper design. So we think in such a way. And the last one is inversion on inversion dependency inversion principle. So higher order module should not be depend on the lower order or module. Both depend on the just abstract layer. Higher order module should not depend on the lower level module. Both depend on the abstract. So in this case, let's assume there is a one user class, and on that user class I just saving the data, and on that user class I directly in constructor I hard coded, I connect a MySQL DB directly. Just I create a new class and I save in MySQL DB. Instead of this design is approach is not supported the the dependency inversion principle, as because in future if we our database is huge large, on that time maybe we have to change our database. It's we may need to switch our database MySQL to SQL server to SQL server or Oracle or anything. On that time our program is broken, as because we have to change in existing in class, and we directly need to change the particular the DB DB class. Instead of that, if we design in such a way that there is a interface, that is database connection, and there is a connect method, and after that I implement for MySQL one class I implement for MySQL, one the connection, one for PostgreSQL, one for SQL server, and after that I use in a class, and I inject this particular the class what I particular interface what I am require, inject this interface and use these things. So it is more generalized. It is not dependent on any database. So we should think in such a way that it should be very very generic. So in this way, our design is more stable. Any changes, we not need to change the entire code base. We don't need it's a very generic thing, so we should follow this generic approach. uh, I think for today, I complete the solid principle, and it's very useful. Well, thank you, bye bye.